Today's lesson will describe how redox reactions can be used for stoichiometric problems. You may remember from Chem 20 that stoichiometry can be used to predict or analyze the quantity of a chemical involved in a chemical reaction. In redox stoichiometry, the procedure is the same as you would have learned before. The only difference is that you'll need to balance the reaction using redox balancing methods. In this example, silver ore is titrated with potassium dichromate. The solution is acidified, and you are asked to determine the mass of silver that was present in the ore sample. Before we can start stoichiometry, we need a balanced equation. Since this is redox stoichiometry, we need to balance using our redox balancing skills. Just as in the previous lesson, begin by listing all of the entities that are present, and then look in the data table on page 7 to determine which are oxidizing agents and reducing agents. Only the strongest oxidizing and reducing agents are used in the balanced equation. You will write out the reduction reaction for the oxidizing agent and the oxidation reaction for the reducing agent, and then combine them to get your net reaction. Once the net reaction is determined, stoichiometry can begin. As in all stoichiometric problems, you will need to determine the chemical amount in moles of your known quantity. In this case, you know the concentration and volume of potassium dichromate, and you can use the values to determine the number of moles of the dichromate ions. Once you have the moles of your known quantity, you will use a mole ratio from your balanced equation to determine the number of moles of silver. Then you can use the number of moles of silver and the molar mass of silver to determine the mass of silver in the ore sample. Now follow along with the steps for the second example. If you like, pause here and see if you can work ahead, and then play the remainder of the video to check your answer. In this question, the scenario involves dissolving a copper penny in nitric acid. The entities are all identified, and the strongest oxidizing agent and strongest reducing agent are determined. The reduction half reaction for the oxidizing agent is written, and the oxidation half reaction for the reducing agent is written. These two reactions are combined to give the net reaction. Now we need to determine the number of moles of copper by using the given mass and the molar mass from the periodic table. Once we know the moles of copper, we can use the mole ratio to determine the number of moles of hydrogen ions. Then we can use the number of moles of hydrogen ions and the concentration of the nitric acid solution to determine the volume of nitric acid required. We will be practicing some calculations and lab skills in class.